So now I'm going to look at just a different situation where these are assembled parts instead of manufactured parts, and we're going to go through the same calculation using the same equation where the material cost is equal to raw material minus the revenue over the number of good parts. Now in this first example we have this gadget that's assembled using 3 different parts: widgets, something, and fasteners, and in addition there's quantities of each and costs of each. So 3 widgets are necessary to make one gadget, and they cost $2.01 per unit. So the question is, how much does it cost? Now this is pretty simple. You would just take 3 times 2.01, 1 times 3, 4 times the 50 cents. But I want to go through and use this equation so we can see how these things work. So if we assume a batch is 1 gadget, we're going to make 1. A widget then, the R for that is going to be 3, the raw material cost is going to be 3 times $2.01. The V, the recycling, there's none. The number of units is 1. We're just taking 1 good unit. So therefore the M, or the material cost of the widget for putting into the gadget, is $6.03. The somethings, the raw material cost is 3. We only need 1 of them, so it's just 3. No recycling, 1 unit. So the material cost is $3 for the somethings part of that. For the fasteners, we need 4 of them at 50 cents. So the raw material, the R, is going to be $2. V is 0, N is 1, so we just have $2. So again, we just multiply that out and then we add it up. And so the cost is $11.03. So remember that, $11.03 if there's no gadget, no defects. The next example then is we're going to look at where there's some defects. So the parts are assembled into the finished product, which we know, but 1 in every 50 widgets are bad, so that's a 2% scrap rate. 1 in every 25 somethings are bad, that's a 4% scrap rate. And the bad parts can be identified before assembly. The fasteners are never bad. What is the material cost? So now we're looking at defects. What is, if there's defects, how will this cost be? Now again, I want to look at, what I've done here is I've added a column that has scrap rate in it. And so we're going to look at these calculations using this equation. Again, a batch is 1. So for the widgets, the raw material cost is still the same, is 3 times 201, which is 603. The V, there's no recycling, but the N, now instead of getting 1 good part out of a batch of 1, we only get 0.98 good parts for the batch of 1. So now the N value becomes 1 minus the scrap rate in this generalized calculation. So therefore, the cost of widgets, given that some are bad, have now gone up. It used to be 601, but now it's 615.3. So it's gone up a bit. For some things, the defect rate is 4%, so now N is going to be 1 minus 4%, which is 96.96. So now the values of this has gone up from 3, now it's going to be 3.125. The fasteners are never bad, so we're just adding that up. Now the cost is $11.28. Now if you remember, it was 11.03, and now it is 11.28. So it's gone up because of the defects in these values. So the next thing now is we need to consider, I also want to add this. The reason that you can do it this way, we'll add them up individually, is that the defects can be found before assembly. If the defects are not found until after assembly, that becomes a little bit more complicated problem, because then after they are assembled and there's a defect, you need to throw away the whole thing. So it's a little bit different calculation. But just remember that it's different whether you find it before or after. Okay, now what we're going to do is I'm going to be including a recycling. So you can see here I've added this sentence, only the widgets can be recycled for $10 per 100. So that means if there's bad widgets, you can sell them back for 10 cents each, which is 10 divided by 100. And they originally cost $2, so that means that the cost is going to be a little bit less because we get to, if they're bad, we get to return them. So now what is the material cost of a gadget? So I'm going to use this equation, and again the V's for this are going to be 10 cents each for the widgets. So let's just look at this a little bit further. If there were 100 widgets and 2 could be recycled because 1 in 50 are bad, so that would be 2 in 100. That means if for a batch was defined as 100 widgets, it would be 20 cents. If the batch was defined as 50 widgets, it would be 10 cents because one would be bad on the average. So if a batch is defined as one widget, which is what we're defining it as, then it would be 0.02 would be recycled. And at 10 cents, that would be $0.002. That would be the V value. So let's look at that. If we include now the V value of 0.002 for each widget, but we use 3 widgets, so it's going to be 0.006. So let's redo that calculation. The only thing we've changed here is we've added this V. It's no longer 0, it's actually 6.006. And that means the cost of the widgets now are $6.147. And if we add all that up, that means that the price actually has fallen. Before it was a decrease in 1 cent. It used to be 128. So you can see that as we add these sort of nuances, it becomes more and more complex. But in general, it's going to be the same calculation each time. So we'll go through several of these in class.